Hello and welcome to the World Green Building Council's webinar for World Green Building Week, Heroes Unmasked, a World GBC Introduction to Net Zero Buildings. I'm Jim Kershaw. I'm the Marketing and Communications Manager at the World Green Building Council. You will have the opportunity to ask questions to our speakers. There'll also be a live polling question through the webinar, so please keep an eye out for that. So this webinar is being held as part of World Green Building Week, and this year the theme is Our Hero is Zero, highlighting the need for net zero buildings and showcasing buildings that are on the journey to becoming net zero as the heroes in the fight against climate change. This week we have events and activities happening all around the world to promote the work that our green building councils and their members are doing in this space. So please show your support by tweeting using the hashtags OurHeroIsZero and WGBW 2017. I'm now going to hand over to the speakers who will introduce themselves and begin the webinar. Thank you very much for joining.
Hello and welcome to this webinar. My name is Victoria Burrows. I'm the project manager for the World Green Building Council's global project Advancing Net Zero.
Hello, my name is Ben Galuza. I'm a principal with Integral Group. I'm based in our London office at Elementa Consulting. Integral Group is a deep green engineering firm, a bit of a net zero specialist, you might say. We've designed and delivered over 80 projects globally of all typologies to kind of various definitions of net zero. We're really excited about World Green Building Council kind of unifying this net zero movement and getting a common definition out to all the GBCs. So we're really excited about the program and happy to be a part of it.
Great. So today we're going to share with you why we think we need net zero buildings. We're going to introduce what we mean when we say net zero and talk a bit about who is demonstrating market leadership by taking action in this space. And we'll also hear from Ben about some insights from Integral's experience of delivering net zero buildings. So first, a little bit about the World Green Building Council. We're a member network of just over 70 green building councils spread across 5 regional networks. You may be joining us from one of these countries today. Our members have approximately just over 900 full and part-time employees, and those green building councils have around about 32,000 member companies. It's quite a large network. And through the work that we've done, we've impacted millions of lives, and we're championing local and global leadership to empower our communities to drive change. As I mentioned, I'm the project manager for our project that's named Advancing Net Zero. In June 2016, the World Green Building Council launched this project as a global campaign to accelerate net zero carbon buildings to 100% by the year 2050. Buildings are responsible for approximately 30% of global carbon emissions, and therefore we feel that decarbonising the world's building stock is an essential part of reducing global emissions in line with the Paris Agreement. And so we've set some targets that we think need to be achieved in order to meet that target. So we think that new buildings must operate at net zero carbon from 2030, and that all buildings must operate at net zero carbon by 2050. So that includes existing buildings as well. And this is a huge challenge which will require significant action from everyone associated with buildings. Anyone who builds, invests in, owns, occupies, supplies resources to and from buildings, which means all of us. But what are net zero carbon buildings? So when discussing net zero buildings, there are many different options and definitions that are thrown about. So we just wanted to clarify, take a moment to clarify what we mean by when we talk about net zero buildings. First and foremost, they are highly energy efficient buildings with integrated design strategies that optimize passive design techniques to harness natural elements where possible, like the sun and the wind, have high building fabric performance and high performance building services, but they also consider for long-term maintenance, and we're talking about operational carbon. So we're really focusing on the in-use operational carbon associated with the building. So when you look at these measures, as we'll hear a bit more from Ben a bit later, these measures combine to drastically reduce predicted energy use cost effectively to both new and existing buildings. But fundamentally, we're calling for the elimination of the use of non-renewable energy that emits damaging carbon into the atmosphere, such as from coal-fired power stations via the usual electricity grids, needed for heating, cooling, lighting, and powering our buildings. Therefore, the remaining energy requirements should come from clean, renewable energy sources, such as solar, hydro, or wind. The difference between a net zero energy building and a net zero carbon building lies in where renewable energy comes from. A net zero energy building will produce all of its energy needs on site through solar generation, for example, whilst a net zero carbon building will produce some of its energy needs through on-site renewable energy systems, and the remaining demand will be supplied from off-site renewable energy, for example, in the forms of renewable energy certificates or power purchase agreements. Most net zero energy buildings are still connected to the electric grid, allowing for electricity produced from traditional energy sources such as natural gas or electricity to be used when renewable energy generation cannot meet the building's energy load due to current technology or cost limitations of energy storage. But over the course of the year, the energy produced on site will meet or exceed the energy requirements of the building. And where a building produces more energy than it needs through on-site renewable energy, the excess may be sold back to the utility as renewable energy credits. So, whilst many net zero energy projects exist globally, in order to achieve the mass levels of net zero carbon buildings to reduce overall global carbon emissions, a key component of this project is decarbonisation of the energy grid supplying our buildings. And through concerted effort to reduce the energy demand of buildings through energy efficiency upgrade measures to existing buildings and dramatically reducing the energy needs of new buildings, we think this target will be achieved much faster. Therefore, our project sets out to raise awareness about the scale of the challenge through increasing awareness and education through our green building councils and project partners to facilitate mass delivery of net zero carbon buildings, to demonstrate that they are necessary, beneficial, and they are achievable. And through our global network, we aim to achieve alignment between approaches and, in some cases, certification schemes that recognise net zero carbon and net zero energy buildings, whilst recognising the need for contextual variances. And we're capturing the work that's being carried out and exchanging knowledge across our platforms, such as through webinars like this, to expedite uptake in the wider markets. So this started following the Paris Agreement in December 2015 at COP21, and that's marked as a truly historic moment in the fight against climate change. Global leaders came together to agree to reduce carbon emissions to ensure that global temperature rise remains within 2 degrees and ideally 1.5 degrees. And that requires significant action within all industries, and this is how we feel the building industry needs to respond. The green building councils that are participating in this project have agreed on a set of key principles that influence their approach to net zero carbon buildings in their markets. The first being that carbon is the ultimate metric to track, as I've mentioned. And we're also talking about in operation carbon. So when a building is in use, what's the actual energy, what's the actual carbon that it's responsible for? The second is that a minimum level of building energy efficiency should be required. And again, as I've mentioned, if we focus on energy efficiency and reduce demand, then decarbonisation will happen a lot faster. Thirdly, that the balance of energy provided should come from renewable sources, and that should have a general hierarchical preference of on-site, then off-site, then offset. And we recognise that in some situations, district systems are appropriate, but really, the energy should be as closely linked to the building as possible. And then finally, that net zero certification programs should continually improve in terms of verification and rigor. So for example, some of our green building councils are including embodied and life cycle carbon within their systems, but others will evolve over time, but there should definitely be transparency in that process. So the green building councils that have committed to developing net zero certification schemes by 2018 are shown here. That's Canada, the US, Brazil, Sweden, the Netherlands, Germany, France, South Africa, India, and Australia. And you may be joining from one of those markets today. And I'm really pleased to say that we've had an incredibly positive response to the project and already made some really significant progress. So the first scheme that was launched was by HQE Alliance in France, the Energy Positive and Carbon Reduction Labelling System. That's in its pilot scheme. It was launched for new buildings in November of last year in 2016. And earlier this year, Canada Green Building Council launched their zero carbon standard. I would really encourage you to go and take a look at that. It's a very comprehensive standard, and that's now been officially launched. And then in August of this year, Brazil launched their zero energy label system. And we're going to see many more systems being launched over the next few months. Our green building councils have identified several different pathways where they can influence their networks towards advancing net zero. 3 of those look at certification schemes, and that might be adapting an existing certification scheme or creating a new one. But we also recognize that there are other routes to advancing net zero within their markets. And so that includes corporate engagement, government engagement, and training and education to really facilitate that mass change. We have some really passionate corporate sponsors on this project. Integral Group are one of them. It's an engineering firm. And we also have Lendlease, the developer, and the supplier Rockwool. And we also have some grant providers for this year as well. Earlier this year in May, we launched a call to action report, which is available on our website. I'm going to go through some of the content of that in a second. But the cover, you may be able to see the image there, features Lendlease's Barangaroo development, which I'll talk about in a little bit as well. In that document, we set out our definition for net zero carbon buildings. It's an umbrella definition that our green building councils can choose to apply how they see fit within their markets. And we say that a zero carbon building is a highly energy efficient building with all remaining energy use from renewable energy, preferably on-site, but also off-site production to achieve net zero carbon emissions annually in operation. We also set out calls to action for 3 key groups of actors that we feel are essential to our theory of change. The first here is government, committing to reduce greenhouse gas emissions from public and private sector buildings by developing national and subnational regulations for all building types to be net zero carbon by 2050 or earlier, by walking the talk, by occupying only certified net zero carbon buildings before 2030, and collaborating with all stakeholders to overcome the barriers preventing net zero carbon buildings. In the business sector, we are asking them to divest from fossil fuel emitting assets. So that means committing to investing in building and occupying only projects that are net zero carbon, disclosing their carbon emissions for all portfolio assets, and certifying all assets as net zero carbon by 2050. And the third group of actors are NGOs to support the implementation of market transformation through, for example, developing net zero certification programs for voluntary uptake, engaging with governments to create roadmaps, incentive programs, and facilitate rapid development of net zero carbon buildings, and educate, train, and mobilize both businesses and the public on the commercial benefits, feasibility, and skills necessary to deliver net zero carbon buildings. And this is our theory of change. We feel that by all of those actors taking action, working together towards the same goal, that will foster the continuous improvement necessary to stimulate the market to meet that increased demand. And that will include some outputs such as inspiring innovation, jobs creation, developing skills and capacity. We'll see deeply energy efficient buildings and boosting the economy, a decarbonised energy grid, and ultimately mass delivery of net zero carbon buildings. And that's how we feel we will reach the 100% by 2050 goal. There are some significant and undeniable benefits to adopting net zero carbon buildings as business as usual. These include, but are not limited to, for investors through the business sector, increased asset value, resilience against climate change risk, meeting corporate social responsibility objectives. For developers, owners, and managers, this might include increasingly attractive buildings to both investors and tenants, generating good return on investment and remaining ahead of the regulation curve. For tenants, that means reputation as market leaders, having cost-efficient operations such as reduced energy costs, and attractive buildings that are pleasant to operate, and that might see increased productivity. For government, at national level, it's all about achieving Paris Agreement obligations. And at subnational levels, such as city and regional scale, it's avoiding the impacts of climate change. And NGOs, such as green building councils and others, the opportunities are increasing education and awareness around this space, offering voluntary green building rating systems, and promoting their work through advocacy and innovation. We're seeing increasing examples of the impact that taking a positive approach towards net zero buildings can have, and our green building councils are walking the talk. So as I mentioned, we have 10 member green building councils committing to developing a net zero certification scheme, and we've already had some demonstration projects and training schemes initiated in 2017, with much more to come next year. They are committed to monitoring their effectiveness and collecting data, and the participants will work together to create a framework for other countries to help create certifications or other pathways towards net zero. We're also seeing increasing examples from the market of businesses recognizing these opportunities and leading the ways for others to follow. And this leadership is incredibly inspiring and demonstrates that awareness of the issues and impacts is increasing and that the market is responding. So, for example, we opened World Green Building Week on Monday with an event at JP Morgan and Chase. They have announced a program for increased energy efficiency within their portfolio and a 100% renewable energy commitment, as well as a very large fund for clean energy financing. Philips also have a target for net zero operations, and we're also seeing some increased activity for RE100, some really positive. I think they've just achieved over 111 corporate entities that have signed up to 100% renewable energy. And then at city and national commitment level, we're also seeing some really positive steps towards carbon neutrality, for example, within the city of Vancouver, Australia, and also Sweden, who are committed to being carbon neutral by climate law by 2045. Over to Ben.
Thanks, Victoria. That was fantastic. Great introduction. So a bit about Integral Group real quick before I move on. We've got 16 offices globally, so from Sydney to London, Washington, D.C., Toronto, Vancouver, and the Bay Area are some of our primary markets. And as I mentioned at the beginning, we've had the opportunity to be delivering a lot of net zero energy and net zero carbon projects in a lot of those regions, as well as other places where we don't yet have offices. So I'm going to go through a bit of the context of what we're seeing in sort of the regulatory space, some macro issues, and then get into a little bit of the detail around the delivery on some net zero energy projects. So I think it's fantastic that the World Green Building Council have developed this framework. It's really kind of upping the ante, and the GBCs have constantly been a few steps ahead of regulation, kind of pushing the envelope and encouraging mass market transformation. It really works. And so we think this is kind of that next step in evolution. As Victoria mentioned, we are now starting to see cities, provinces, states, and councils increasing the ante. So that's really exciting. The key thing is sort of the metrics that we use to measure, the performance of buildings. That's incredibly important. I think the idea of measuring carbon annually in operations is significantly important, and I'll get into that in just a moment. So, for the first time since 1882 in the UK, it was a big coal country for a very long time. They had an entire day where they burned no coal. So that was an impressive feat after, well over 100 years of using coal. And in, the early 2020s, it's going to be the end of coal in the UK. What that means for the grid is that it's rapidly decarbonizing. And this is why the kind of annual operation carbon metric is important, because the carbon emissions of the grid are not static. They're actually rapidly changing. And it's actually caught us here in the UK a bit on the back foot, because 10 years ago, the London Plan and its energy policy was a world-leading policy based on the carbon intensity of the grid at that time. And so systems like combined heat and power were outperforming every other type of system that could be designed and delivered from a carbon emissions standpoint. However, as the grid has decarbonized, gas CHP is no longer outperforming other alternatives. And so right now, today, using all electric heat pump based systems are actually less carbon intensive than gas CHP. And as the grid decarbonizes, it's going to narrow the solution set available to projects. So it's very important for the GBCs, as they're developing kind of their metrics, their recommendations and design guidelines, to be thinking ahead for what the future grid will look like. It's also important to be, I know there's a lot of talk and excitement around biofuels, and it's important to consider how long it takes to sequester carbon into those biofuels for certain types of wood. That might take 30 or 40 years to sequester all that carbon. And sort of the race against climate change, it's a time-based race that's happening, and we need to be considerate of when we're emitting carbon into the atmosphere. And so sort of my personal stance and belief that we shouldn't be using biofuels at this time, especially ones that took, say, 40 years to sequester all that carbon. It's better to leave it locked up. We can certainly be looking at these types of biofuels later on, perhaps in another 30 to 40, 50 years, once we've dealt with the big issues around fossil fuels. It's also important when we think about what types of energy sources that we use in cities, in particular, when it comes to human health and air quality. So buildings have a big part to play in improving air quality around the globe. And it's not just an issue in the developing world, it's an issue for us in London. In the lower right-hand corner, you'll see an image of London in 2015. So very similar challenges in all major cities, and we don't want buildings to be a part of the problem. We want them to be a part of the solution. 92% of the global population, according to the WHO, are living in sub-optimum air quality lifestyles. The good news is that kind of the economics of the modern technology that we have and the scalability that is reaching the major global markets, we're sort of at this maturity phase where prices continue to fall. And particularly for batteries, every doubling of lithium ion battery production has resulted in a 20% decrease in the cost of those batteries. So that's very significant when we start looking at combining renewable energy and storage, whether it's on-site or off-site. And just the Tesla factory alone in Reno, Nevada, at the time that it was coming online, was set to double the global production. That's just one facility that Tesla was building. And so there's lots of facilities coming online. There's lots of new battery technology. It's not just lithium ion. There's other competitors that are coming into the market as well, which is great. It's very exciting. So all of the research that's coming out of institutes like Bloomberg's research arm, as well as Lawrence Berkeley National Laboratories, are forecasting that solar plus batteries are going to be cost competitive, and sort of we're going to reach that parity where it's the most cost-effective way to deliver energy to the grid or to buildings by 2020 or 2021. So another thing to be considering as you're developing your frameworks for your local regions. But this isn't something that's just limited to the developed world. We're seeing these disruptive business models coming into play with sort of advanced technology that's available to us now. Lots of pay-as-you-go technology solutions for people who are off the grid. So we're going to see, there's 3 billion people that currently do not have electricity. They're going to leapfrog the developed world. They don't have the burdens of a kind of heavy utility infrastructure that requires a lot of maintenance. I think they're going to go flying right by us. So it's very exciting that this is not going to be limited just to the developed world. And this is just one example of a company on Gaza that's working in that space. So if we can deliver entire grids that don't require combustion, and we can deliver electric cars and electric vehicles that don't require it, can we deliver buildings without engines? This is a quote from Bjarke Ingels of a big architectural group. And I think he's right. I think that we can. Certainly at Integral Group, it's something that we've been practicing for 10 years now, and it's very exciting to see this coming into the mainstream. But as Victoria mentioned, it's really important that we don't just look at kind of the renewable energy technology. First and foremost, in order for us to solve this problem and have enough renewable energy to go around, we have to look at how we're using that energy first. And so key thing is basically going from business as usual or baseline building, your typical building, you want to reduce the demand by half through improving the envelope, looking at energy recovery, reducing your internal process loads, your computers, your plug loads, using demand control. And once you've done that and you've cut the loads in half, then you want to double the efficiency of your typical system. So that allows you to reduce your building energy consumption by 75%. So now the amount of renewable energy that you need is significantly less. And that kind of formula has seemed to check out for us when we're working on either new build construction as well as retrofit. We tend to see about a 70 to 80% reduction when we follow this approach. This is a kind of an idea and a concept that came out of the Rocky Mountain Institute, this factor 4 concept, if you want to look into that further. So when we look at the building envelope and reducing loads, from a maintenance standpoint and kind of looking at operational issues that come with designing high performance buildings, we think that dynamic glazing, electrochromic, or switchable glass, that these types of things and solutions are going to allow us to drastically reduce the load. So that's attacking that demand side first, so that your mechanical systems that condition spaces don't have to work as hard. They don't need to be sized up as large, so you actually are saving money on the mechanical side as well, or potentially even eliminating mechanical systems. We think that passive house for air tightness, U values in terms of the thermal resistance and G values from a solar heat gain perspective are certainly valuable metrics for any GBCs to be considering and targeting. I think you want to be careful about adopting passive house full stop in terms of the limitations it may place on design team flexibility to reach the same kind of results in the end. But it's certainly a great starting point in terms of really kind of testing the building fabric and making sure that you're getting the performance that's desired. When we look at the kind of like the building fabric and the envelope, this is just a simple kind of a simple but high impact move that you can make. It's something that's come out of mostly the tropic region around the globe of using outdoor circulation with instead of indoor circulation, which can be a bit bland and boring on the left-hand side, to something that can be really special and giving people access to nature. So you're kind of really tapping into people's desire to be connected. The kind of exciting part for this on an energy perspective is that you've probably just eliminated 15 to 20% of your floor area that no longer needs to be conditioned. So that's a big move, and it can have a lot of impact and save a lot on costs as well, because there's a bunch of systems and things that you do not need to install. We're also seeing a trend towards tumbling plug loads. So from 1998, Apple's original computers, their standby mode was 35 watts. So it's not just the peak plug loads that we're looking at. It's also about when the computer device, machine, when it's off, that it's really off, and so I think that's important to understand as well, when you're looking at energy, is that when you're not using a system, whatever that system might be, that it's being turned off. The reason why plug loads are so important is once you've done a fantastic job on the envelope, the lighting, and the HVAC, the plug and process loads end up being half of your building's energy consumption. So to get down to net zero, you have to address the plug loads. There can't be anything that's unregulated or processed. You've got to address the total building energy. Then that takes us on to using smarter systems, the way that we move air around buildings, and really trying to optimize that through things like demand control, ventilation. So this is just a little kind of snippet of a package of systems that we tend to use on our net zero projects. I'm not going to go into too much detail on what happens at the zone level from a heating and cooling standpoint. But what I think is important is that we seem to be kind of constantly ending up back at using electrically based heat pump systems that use low grade heat. So what that means is that we're supplying chilled water and hot water out to our zone level distribution systems closer to the ambient temperature, whether that's the groundwater nearby or the outdoor air. And that allows the heat pump to operate very efficiently because it has to do less work to generate that heating or chilled water. And we're also seeing a lot of benefits from using energy recovery on the ventilation side. All of the science around health and quality in the indoor environment is saying that we need to be giving people a lot more fresh air in order for them to stay healthy and kind of be at their highest performance. But we don't want to bring all that fresh air in all the time. So that then brings in the importance of demand control ventilation. So only ventilating a space when it's occupied. So that little package of solutions, I think, has high impact when you're doing net zero projects and is a good starting point. It's also important that when you're looking at the envelope and the plug loads and the systems, that you're doing it in an integrated fashion, that you're not doing it in an additive fashion. You want to design the whole system, the whole building simultaneously in a collaborative fashion. We're also seeing benefits, from technology. Users are being empowered by it as well to be able to control their space. This is an app. It's called Comfy. It's just one of the ones that's out on the market, but it's pretty exciting. It allows people to kind of say if they're hot or cold, and gives them more control over their environment. And the system also learns how the building is operating. And so it can actually turn the system down when people are not in. It also kind of learns their preferred patterns of behavior. And there's energy savings that have come from this as well. They've been finding in a lot of buildings anywhere from 10 to 30% energy savings because the app is able to optimize the building systems. It's important as well to have real-time dynamic feedback on your building's performance. So the lead dynamic plaque is a great way to do that. And now their new system ARC that's coming out. So having that real-time feedback as the building is going through its operational phase is incredibly important. So that way you can kind of head problems off before they arise. You don't want to look at it at the end of the year and then find out, oh geez, we could have saved 10 or 20,000 kilowatt hours this year if we had known that electric space heater was plugged in. So I'm going to go through some projects. I'm going to move pretty quickly through these. So just stick with me, and it's more of a kind of showing what we can do, because these are some really beautiful projects that are being delivered. Net zero doesn't mean that it's, necessarily kind of like an off-grid straw bale thing from the 60s, which I love, but it's not for everybody, and so net zero buildings can be a lot more than that now. They can be really beautiful pieces of architecture. So this is in San Jose. It was an old bank branch kind of building that was retrofitted into an office. So Hopefully, JP Morgan Chase see this and may want to do the same with their branch offices. So this was one of the first net zero office buildings, and it was the first one certified. It was delivered in 2007. It had a ground source heat pump system, super insulation on the roof, photovoltaics, and kind of use the photovoltaics as well for shading. This is DPR's office in San Francisco, a 2-story renovation with a full seismic upgrade. They have photovoltaics on the roof and solar thermal system. They used a VRF system, so again, another heat pump type of system. They've got energy recovery on the ventilation. They've got great daylight throughout, so the lights are able to stay off for a lot of the year. They also have some ceiling fans that increase the air movement and improve occupant comfort. It's also transit oriented. It's close to the urban core in San Francisco, so it's great. You don't have to drive to it as well, which is a big thing in California. This is DPR's roof. Again, you can see the photovoltaics and the solar thermal, but off in the background, you can see the Exploratorium Museum. So now we're seeing kind of net zero neighbors cropping up as well. So, going from office buildings to museums, which have a lot higher intensity internal process loads and demands. So that's quite a feat as well. This is the Packard Foundation. It's a new build construction, beautiful project. It's won quite a few awards from the AIA, the American Institute of Architects. It's operating net positive energy. It uses heat recovery chillers, thermal energy storage. It has shading on the exterior, and then most of the spaces it utilizes active chilled beams. So again, that same kind of suite of technologies, again, energy recovery on the ventilation system. This is the Bullet Foundation up in Seattle, and it operates net positive, but it's certainly, I think it's one of the tallest net positive energy buildings. And so, which is quite a feat of of energy, and certainly in Seattle, where they do not get a lot of sunshine. So these buildings are not just, for kind of the southern regions and the around the tropics. They can be delivered in northern climes as well. This is Sharp Development's 435 India Way. So it's a developer-led retrofit. It's net zero. It produces as much energy from a cost perspective as it takes from the grid each year. And what's, I think, unique about this project is that Kevin Bates, the developer, has basically kind of cracked the code, especially in the Bay Area market, to be able to deliver these types of projects more profitably than business as usual. And so this is how he goes about delivering all of his projects now. Kind of shifting back to the UK, this is one of my favorite projects, and was a major inspiration for me when I was coming through university. This is the BEDZ development. So it was one of the first. It's community scale, so great project, and kind of for historical reference, and it's been around for a long time. So that's good to just have that continuity of projects. And going from communities, we can even do lab buildings now as well to be net zero. This is the Venter Institute. So they've got this kind of giant sail of photovoltaics that bridges between the office block and the laboratory block. And so it's not limited any longer just to kind of offices and residential. We can do it for kind of high energy intensity buildings as well. The math in terms of balancing the equation certainly gets a little more challenging for labs, but it can be done. And we're not even limited just to individual buildings now. We're scaling up. Entire cities are looking at doing these kind of decarbonization roadmaps, as Victoria mentioned. So this is in Cambridge, Massachusetts. And we're starting to see that take hold globally as well. And it's something that kind of the London market is also interested in. Toronto has done a fantastic job with their metrics. They're looking at energy use intensity, so the kilowatt hours per square meter per year as one metric. They also then look at the thermal energy demand intensity, which is just a raw calculation of how much heating and cooling energy do we need. So it's a reflection of the fabric performance. And then finally, they look at the greenhouse gas emissions as well. So they track all three, and they have three metrics. I think it's a really nice package solution that should be replicated. I think Vancouver have gone the same way, and the London community is pushing very hard for something similar. The added benefit of that is you get free resiliency. So if you were to lose power in these kind of super passive buildings, you can make it, a few days or a couple of weeks without getting into a situation where your buildings become uncomfortable or unoccupiable, both in heating and cooling. So you get that added benefit, and it's important to consider that. And it's not limited just to kind of the more temperate climes. The School of Design and Environment at the National University of Singapore is now delivering a net zero energy project for their students. So it's really cool to see all these different barriers being broken around the globe. Thank you.
Thank you, Ben. It's great to see where the boundaries are being pushed, and that the sort of scalability of some of these concepts as well. So that being said, I'm just going to touch very quickly on a couple of other case studies that we're aware of before we jump into some Q&A that we may have some time for. Firstly, Barangaroo, as I mentioned, this project features on the front cover of our report that we launched earlier this year. It's this high-density multi-use complex you can see in the front of the screen. It's part of the Climate Positive Development Programme, and it aims to be carbon neutral, water positive, and create zero waste emissions, as well as contributing to community well-being. It uses a district cooling system from Sydney Harbour as well, which is very cool. And you can also see in the background there Sydney Opera House, which aims to be carbon neutral by 2023. Sydney Opera House actually features in our World Green Building Week campaign for our Hero is Zero. We show that any building can be carbon neutral, even iconic ones like Sydney Opera House. So look forward to hearing more about that. Here in the UK, another exciting project is from the University of Nottingham. It's the first carbon life cycle neutral laboratory building to be built in the UK. It's got super high energy efficiency standards and on-site renewable energy, and the excess energy that's generated on site will pay back the embodied carbon associated with the materials and construction within 25 years. This is another great model that we tend to talk about. It's Energy Sprung, originating from the Netherlands. This is a financing model for whole house social housing retrofit to zero energy standards. It aims to provide desirable and comfortable and affordable homes for the occupants. It's an insurer-backed and energy performance guarantee by the contractor, which guarantees energy savings so that the tenants have guaranteed energy costs, energy bills. And that also creates greater quality of life and achieves reduced emissions at mass scale. You can see here the houses are being completed at street by street level. So it's a really great initiative that is expanding outside of the Netherlands into other European markets as well. And then finally, another model is Kaupuni Village in Hawaii, which is the first net zero energy affordable housing community to be built in Hawaii. It's also created a sustainable community. It's really had community at the heart of this development, and it was created in very close collaboration with stakeholders. They reduced energy demand by 40% and were able to supply the remaining requirements by on-site solar panels. So the development promotes healthy and sustainable lifestyles, and they are expanding that model. It's been so successful as well, which is fantastic. Okay, so that's the end of our presentations. We have a few minutes available for question and answers. So you are able to use the chat box if you have any questions. I know that we have a couple that have come through. Just bear with us. I have a question here for Ben. Is there ever a compromise between tactics to achieve net zero carbon and health and well-being benefits?
That's a great question. In terms of compromise, I don't think we don't need to compromise. I think we can sort of have our cake and eat it too. And so the project that I showed for DPR construction, we also engaged with the UC Berkeley Center for the Built Environment. They have a post-occupancy survey tool, and they have a very robust database of buildings in that post-occupancy tool. I think they have in the thousands of buildings. And the typical building has about a 73% occupant satisfaction with their building. That's kind of your average building. Only 73 out of every 100 people are happy with the building that they're in. DPR's office had a 94% occupant satisfaction. I have another project that's an ultra low energy lab at Pomona College. It's probably one of the highest performing lab buildings in the US. And they also came in at 94% occupant satisfaction. So we've been going back into our net zero energy buildings and doing these occupant satisfaction surveys, and it looks at general satisfaction and then all of the key metrics around lighting, acoustics, thermal comfort, air quality. So it really kind of gets the whole gambit. And we've outperformed the typical building usually by 10 to 20% in every key metric. So I think we can certainly kind of have it both ways. And it seems to, based on the data we've got so far, that net zero energy buildings actually create better buildings for people as well.
Well, that's great. I guess through rationalizing and designing out some of that redundancy within the systems, you can focus on some of the other areas of the building itself.
Yeah, it's just amazing because it's sort of like the architecture, and the architects, and contractors deserve a lot of the credit with this because then the systems that we design don't really have to work very hard. So a lot of it comes down to their efforts, and it makes it pretty easy because the systems don't have to push around a bunch of air to try to meet the loads, and that improves comfort.
And you mentioned automated systems, but there must be a huge piece to do with the engagement of the people who are occupying the space, so they know how the building operates to make sure, because we're talking about long-term performance, right? So you need to sustain that performance
every year, right?
Yeah, year on year.
Yeah, and there certainly is. In the UK, it's called kind of soft landings, and LEED, has their enhanced commissioning credit. That post-occupancy commissioning period, it's really important, for larger buildings that have active systems to be kind of continuously commissioned over the first kind of 3 to 9 months to really kind of optimize them and work out the bugs. Because every single building that we deliver is a prototype. They're not these kind of like standard things coming off the production line. So each building really does need to go through a robust commissioning process if it's going to have active systems. There's certainly a lot of ease and simplicity that comes from just full passive design. If you're in a climate and typology and culture where you can get away with that. Certainly preferred. So the most efficient system is the one that doesn't have to run. So that's kind of strategy there.
We will launch the poll as well while we're talking about this, because we wanted to ask the people that are attending today what they see as the main barrier to net zero buildings in their area, because as we're talking to various different markets, we get different perspectives, but there's often some very common themes through why people feel that net zero buildings aren't taken up en masse. But in some cases, we're seeing some really great pioneering examples from government taking leadership. So we mentioned the city of Vancouver, for example, that are taking from a from a city level, what they are enacting to support and provide those mechanisms and initiatives to sort of inspire and help developers along that journey. But we see others as well, such as I mentioned Sweden as well, carbon neutral by 2045, and in Australia there's the national carbon offset standard. So I think we're seeing the regulation barriers being dropped, hopefully.
Yeah, I think we've certainly seen the same thing in a lot of those markets, and the markets where we've been heavily active, is that there's always a few sort of lighthouse or lamplighter projects that are out on the horizon, kind of pushing the envelope and guiding the rest of us along. And then there's sort of that phase where once you have the first one, and everyone's has 20 reasons why they were able to do it, and why their project couldn't potentially achieve the same. But then once you get kind of, there's the first mover, but then there's the second mover, and then the third, and it's those second, third, and fourth movers that actually really start to change the mindset of the market. And then everyone says, why not me? I want to have a net zero building. And then once you kind of have the evidence base there to do more, I think then regulation starts to say, okay, it seems like the market is there, the skills are there to deliver this. Let's start asking, everyone to do more.
And that will lead to the finance piece as well, right? The expense that people tend to associate with net zero buildings. You mentioned the price per unit of PV and wind coming down. We've seen the same for LED lighting.
Absolutely.
Lots of control systems within buildings. It's becoming a bit easier.
Yeah,
maybe.
Absolutely. And I think it was interesting. I was just having a conversation with someone last night about this at the London Energy Transformation Initiative launch event. And we were talking about if there's sort of, sometimes you pay a premium for net zero or, deep green or ultra sustainable. So I think a lot of times it's really just how we position our projects, and that's because the price is elastic, because as I mentioned, every building is a prototype. And so it's never been done before. So if we, as we're taking the project out to tender, this new prototype, and we say, this is the most advanced building that's ever been designed, the price is going to go up. Yeah. However, if you're a little more kind of savvy about it, and as you develop the design and the terminology, you're using kind of simple techniques that are all about kind of speed of delivery and kind of efficiency of being able to erect the structure, off-the-shelf products, simple systems, easy to commission, easy to operate. So it's a lot of it is around the language that we use to describe net zero and sustainability. I think if we can sort of actually use the mainstream language that's in the construction industry, we can actually start to bring some of these cost barriers down. But a lot of it just has to do with how we communicate it. So I think if we move away from the flashy kind of bling sustainability more towards something that's more fundamental, that's in kind of common language, and then let's focus on the results, focus on the outcome, the operational carbon of the building as just a metric, at the end. It's sort of like, what came out the other side, of this process? And then we can brand it after the fact. I think we have a tendency to brand our products before they've been built. I think we should be branding them after they've been in operation for a couple of years. Yeah,
absolutely. Yeah. Okay, well, the poll results look like 56% think regulation, and in third is the expense associated. So that's a really good. Positive.
Yeah, it's a good trend.
Yeah, absolutely. Yeah. And this, as you said about the more that we can demonstrate the positives, and the more that the market uptake increases and responds to this demand, then hopefully the governments will take notice and enact some of that regulation change.
I think one of the big things on regulation change that we need to see is moving towards these performance-based metrics. So really looking at using benchmark data for the existing building stock as the baseline. And then saying we want to see a performance improvement at the end of the first or second year. So whatever regulation can do to shift towards that mindset, we'll start to kind of then tackle the kind of the expertise and knowledge barriers as well as the cost barriers. So that's a key thing that regulation can do. It doesn't have to necessarily be mandatory, but make it that everyone has to kind of say, what do you forecast your energy and carbon consumption will be on a performance basis? Maybe make it voluntary for a couple of years, create alternative compliance paths for folks that don't want to go down the kind of standard modeling routes or prescriptive routes. So that way we kind of create more flexibility.
Well, and I think, as you mentioned earlier, buildings historically have been part of the problem, and now it's time for them to be the solution. Okay, all right. Well, I think we'll leave it there if that's all the questions we have, and we've completed the poll. So thank you very much for attending this webinar, Heroes Unmasked, a World Green Building Council Introduction to Net Zero Buildings, brought to you as part of World Green Building Week. I hope you are able to explore some of the other events that are happening in your area for World Green Building Week and be able to share the message about net zero buildings. Okay, thanks very much. Thank you for joining.